Hi, okay, so this video will be about forces. Okay, so before I go through the main worksheet, which is this one, I will first be going through some notes so that you can try and answer these questions on your own, okay? So, okay, what is a force? So whenever we push or pull an object, okay, we are said to exert a force, okay? So that is a force. So it's either when you push or when you're pulling an object, okay? So what are the effects of forces? Okay, the effects of forces, just remember 5 things. Firstly, when I push something, okay, I'm starting an object when it's to move, okay? So example, when you're rolling a ball, okay? Now, when you are acting against the opposite direction, you're stopping a moving object, okay? So when you start an moving object, okay, and you stop a moving object, okay? So these two are the effects of forces. Thirdly, changing the speed of a moving object. So such as like throwing a ball instead of simply just rolling it on the table, okay? Fourth, changing the direction of the moving object, okay? And last but not least, size and shape of the object, okay? So just remember these 5 effects of forces, okay? So what do you use to measure forces? Okay, you use a spring balance, okay? And the SI unit for force is newtons, okay? And you can use it to represent by just capital N. What is friction? So friction is when it acts against the surface when you're rubbing two objects together, such as like when you're rubbing your hands together, you notice, okay, that your hand starts to become warmer. Okay, so sometimes when you go to like cold countries, you tend to like rub your hands together, okay, and that produces friction and heat. Okay, and friction always opposes the movement of an object. Okay? Okay. So weight, what is weight? Is a measure of the force of gravity that is being exerted on the object. Okay, do note that mass and weight are two different things. So what is the difference between mass and weight? Okay, for mass, it measures the amount of matter in an object versus weight, you're measuring the force of gravity exerted on the object. Okay, so do note that there is a difference between mass and weight. Don't mix both of them up, okay? And the units are also different. So mass is in kgs, weight is in newtons, okay? So now I'll be going through the worksheet. You can read the notes first to try and understand, okay, what is going on, okay? And try and read your textbook also before attempting the worksheet, okay? So this worksheet, you should watch it when you have done the worksheet lah, okay? So, okay, I'm gonna split the screen so that we can compare as well, okay? Now, forces, what effects of forces? Okay, look at, change the direction. So here, direction, okay, of an object. You can also change the shape of an object, okay? Okay, stationary object to move. So when an object is not moving, you're causing it to move and you stop a moving object. Okay, so you see over here, stop a moving object, stationary object to move. Okay, okay, so you can either increase or decrease the speed of the object. So changing speed of object. Okay, now, SI unit of force is Newton, okay, with, you can represent by a capital N. And what do you measure force? Okay, it's a spring balance, okay, spring balance. Okay, so friction, okay, slows down the motion of a moving object. Okay, how does it slow down the motion of a moving object? You notice over here, okay, the moving object is moving towards the right side. So when there is friction, it will move in the opposite direction, which is the left side. So that's why it will slow down, okay? Because it's moving opposite you, okay? So let's say example, you're like the moving object, you're wanting to go right, but then someone keeps pushing you to the left, okay? So that is kind of like friction, okay? And do note where is friction acting on, okay? Is between the moving object and the surface, okay? So this will be very important because it'll help you answer one of the questions later on. Okay. Okay, so positive effects of friction include when what do you do on paper? You write on paper. Okay, during wet weather conditions, the roads are very slippery. So when you have grooves on the tire, it will help to have better grip on the road. Okay. Okay, negative effects of friction. Heat produces heat. Okay, why? Okay, it can be negative and positive. Okay, so depends on the situation, but more of the times it's negative. Why? Because heat is produced, right? Okay, your materials tend to wear out. Okay, and also we did mention that it reduces speed of moving object over here. Okay, so it will help you answer this question. Okay, now frictions can be reduced by applying oil and grease. Oh wait, sorry. Let me highlight that part. Okay. Oh, I think it's not highlighting. It's okay. Okay, oil and grease. What are oil and grease known as? Lubricants. Okay. Okay. You polish surface to make them smooth. Okay, so these two, when adding lubricants, polishing, okay, it all helps to reduce friction. Okay, why when you apply lubricants, okay, it will help reduce friction because it's like you're applying a layer of liquid. Okay, it's helping you to reduce it. Example, let's say when you compare when it's dry and when it's wet, the floor is wet. Okay, what do you notice? You will tend to slip more, okay, when you are on a wet floor. Okay, so that is kind of like a lubricant. It helps to reduce friction. So that's why you tend to slip more because there is lesser friction, okay, between your shoe and the ground. Okay, so this is for the first page. I'll now move on to the second page. Okay. Okay, we'll use wheels between sliding surfaces. Okay, uh, to reduce which can help to reduce friction as well. Okay, wheels or rollers between surfaces, layer of air. You can go and search out on Google what's a hovercraft. Okay, they use a layer of air between surfaces, so this also helps to reduce friction. Okay, so these 5 things help to reduce friction. Okay, now, oh wait, sorry. Okay, we'll calculate the resultant force and circle the direction of the ball. Okay? Okay, look at this. Okay. Now, if I am applying 10 newtons to the left, 10 newtons to the right, there is no resultant force. Why? Because I have 10 to the left, 10 to the right. Okay, you minus both together, it will give you 0. So that is why it will stop. Okay. Now, look at the second one. I'm moving 8 newtons to the right, 2 newtons to the right. Both is in the right direction. Okay. And if you add up 8 plus 2, it will give you 10 and it will move to the right. Okay. Okay. Now let's look at this. We have 5 newtons to the left, 3 newtons to the right. Which one is more a greater force? It will be to the left. Why? Because left is 5 newtons, right is 3 newtons. So when I minus both of them, it will give you 2 newtons. Where is the force greater at? It's at the left side. So it will move to the left overall. Okay. Okay, let's try the next question. Okay. Okay. So when a block of metal is hung in the air from a spring balance, okay, again, let's recap what is a spring balance. It's used to measure force, okay? So the reading will be 9.6 N. Okay, what is the weight of the block of metal? Okay, so you see, I'm measuring the block of metal using a spring balance, which is used to measure the force, which also can be used to measure the weight. Therefore, the weight of the block of metal will be 9.6 newtons. Okay, okay, now assuming that the weight of 1 kg mass is 10 newtons. Calculate the mass of the block. Okay, so when there's a lot of numbers, okay, don't confuse yourself. Okay, look at the units first. 1 kg mass. So meaning this is your mass. 10 newtons is referring to the weight. Now they want you to calculate the mass. So first thing first, what should your unit be? Your final answer should be in kg. Okay. So if I have 1 kg of weight, which will be equals to 10 newtons, now I have 9.6 newtons here. So when you do the calculation, you get 0.96 kg. Okay? Okay. So next question, the weight of a man on Earth is 600 newtons. This 600 newtons is referring to the weight. Okay? So suppose the gravitational field strength is 10 newtons per kg on Earth. Okay? But 1.7 newtons per kg on the moon. Now we need to find the mass on Earth. Okay? Mass on Earth. So when you look at gravitational field, which number should you use? Should you use the 10 or 1.7? You should use the 10, okay, because it's on Earth. Okay, so the 1.7 doesn't help you in this question. Okay, so now you calculate the mass of the man on Earth. It will be, you have the weight already, you have the gravitational field strength, so now you need to find the mass, which will give you 60 kg. Okay, now we need to calculate his mass on the moon. Okay, so when we look back on this, okay, I didn't write it in the notes here, but do take note, okay, when your mass, okay, it does not change regardless of location, whether I put you on the moon, put you on Earth, put you anywhere, your mass does not change. This is because look at the definition of mass again. It measures the amount of matter in an object. Will the amount of matter that you occupy change, okay, regardless of your location? The answer is no. Okay, it will still occupy the same space. Okay, so that is why your mass will stay constant, whether you are on Earth or on the moon. Okay, so thus the mass of the man will still be the same, and your answer will be 60 kg, which is the same over here. Okay, weight on the moon. Okay, your weight changes. Okay, why? Look back at the definition of weight. What is weight? Measure of force of gravity exerted. Okay, your weight changes because look at the gravitational field strength. 10 newtons per kg on Earth, 1.7 newtons per kg on moon is different. Okay, therefore your weight will change. So calculate the weight. It should give you 102 newtons. Okay. Okay, let's look at question 5. So how do you reduce friction? Okay, you can refer back to this one that you did over here. Okay, how do you reduce friction? Okay, the most common method is by using wheels. Okay, hovercraft, layer of air, heavy load also use wheels. Okay, so most of the times it's either wheels, lubricants, layer of air. These are the 3 most common methods. Okay. Okay, let's look at diagram 6. Okay. Okay, you need to draw arrows, label the arrows to indicate the direction of all forces that are acting on the object. Okay, this question is, you have to be very careful. First, all directions, of all forces, okay, need to tell me the 3 forces that you know of. Okay, so what are the 3 forces that you know of? Okay. Secondly, you need to draw the arrows correctly. Okay. Now, when you draw the arrows, yes, it may be in the right direction, but you need to draw correctly. What do I mean by correctly? Example, when you have frictional force, do you draw your frictional force here, that the arrow is here, here, or here? Have to be very careful. Okay, the answer should be here, in between where your block, where the person is moving the object and the floor. Okay, do not draw your frictional force over here. Okay, it's like at the layer of air, there's no friction there. Okay, so you have to draw it over here. Okay, I will send the picture on how you are supposed to draw it in a separate file, so you can refer to that. But I want you to try this question first. Okay, so what are the 3 forces? 3 forces that you should name, and the 3 correct directions. Okay, so the 3 forces should be, okay, gravitational force, where we learned over here, gravitational field strength. Okay, you have secondly frictional force. Okay, yeah, and you can figure out what is the third one. Okay, okay, so let's look over here. Okay, question 7. This question, right, is kind of related to question 6. So you can try answering what is the third one. You can get your answer from question 7 as well, okay? Okay, you are tasked with building a roller coaster. Factors you should consider when you design a roller coaster. Okay, what do you notice about roller coaster? Again, factors you have to consider. Talk about forces again. What are the 3 forces you know? Gravitational force, frictional force, okay, the pushing or forward force. Okay, so you need to consider size of gravitational force. Why? Because when it's a roller coaster, you're acting against gravity as well, right? Because you're going up, going down. Okay, so you need to consider this. Frictional force, okay, between what and what? Is between the wheels of the roller coaster and the tracks. So that is where your frictional force come into play. Size of the forward force, usually forward, okay, or you can say, okay, but most likely it should be forward force because your roller coasters is moving from back to front, right? So it should be a forward force. Or you can tell me pushing force, I think I can accept as well, okay? Let's look at question 8. Okay, so these are more of the application questions from 8 to 9. Okay, I didn't write pressure in my notes, so I'll briefly go through now. What is pressure? Okay, so when you have pressure, it will be force over area. That is your calculation on how to calculate pressure. It will always be force over area. Okay, so you look at this, force over area. And what is the unit for pressure? Can either put newtons per meter squared, which is this, okay, this, okay, or you can tell me pascals, which is PA, okay. I want you to read about pressure first before you attempt these questions, because these questions is more application based, okay, and it will help if you can read your textbook so that you understand better, okay. Okay, let's read the question now. Tasked to design a car park on the top floor of the condo that can accommodate 10 cars. So I need 10 cars to accommodate to. Okay, each car has a maximum mass of 2000 kg. Okay, 2000 kg is the mass of one car. Material you are using withstand a pressure of 500 newtons per meter squared. Okay, how large must my car park be? Meaning I'm talking about the area. Okay, I need to know the area. So now first thing first, you need to find what is the total mass of all the cars, because why I need to accommodate to 10 cars, correct? But now your 2000 kg is only for one car. So I need to accommodate to 10. So when I do the calculation, you should get 20,000 kg. Okay, now the weight of all the cars, okay, yes, this question is a bit tricky because you will need to memorize what is your gravitational field strength, okay, on Earth and on the moon. So if the question never give you, you should assume that your gravitational field strength on Earth will always be 10 N per kg. So for this question, you also assume because the question never give you, so you need to find your gravitational field strength on Earth, which is 10 newtons per kg. Okay, 10 newtons per kg. And the total will be 200,000 newtons. And that is the force that is acting on it. Okay, now how do you find the area? Okay, using this formula, pressure equals to force over area. You will take area equals to force over pressure. When you calculate the force, which is your weight of all the cars, 200 newtons, 200,000 newtons, divided by the pressure over here that they given, which is 500 newtons per meter squared, your answer should be 400 meters per, 400 meters squared, okay? So this is your area of the car park. Okay, this means that is m to the power of 2. Okay, so I don't have the I can't do the like this thing, so I have to use the caret sign. Okay, so but it's still the same thing. I just want you to express it in meter squared. Okay. Okay, elephant that has a mass of 3000 kg, each of its foot has a surface of 0.4 meters squared. Okay, this question you have to be very careful. Okay, first thing first, your 3000 kg is referring to mass or weight? Answer is mass. Each of the foot has a surface area of 0.4 meters squared. So one foot is 0.4 meters squared. But an elephant has how many foot? Okay, so you need to find the total area, yeah? Okay, lady, mass of 45 kg. Okay, and then she wear heels that has a surface of 0.01 meter square. Each heel 0.01 meter square. But how many heels does the lady have? Okay, need to find the total surface area as well. So now we assume that there is equal distribution of mass on each foot. We need to find the maximum possible pressure that can be exerted by the heel. Okay, this question, because there are two information given, one for elephant, one for heel. Okay, but now part A only wants the heel, so you should focus on two numbers only, the 0.01 meter squared and the 45 kg. Okay, now we need to find pressure. What is the formula for pressure again? It will be force over area. Okay, okay. This question did not give gravitational field strength as well, so you will assume that the gravitational field strength on Earth is 10 newtons per kg. Okay, so weight of the lady, it will be 45 kg. You need to find times your gravitational field strength, which will give you the force, which is 450 newtons, which is the weight of the person. Now to find pressure, force, which is 450 newtons, divided by total area. Okay, why did I times 2? Because the person has 2 heels, correct? So if I have 2 heels, okay, I need to times 2 for the total surface area. So pressure divided by area, you will get 22500 PA, which is pascals. Okay, and this is your pressure. Calculate maximum pressure that can be exerted by the elephant's foot. Weight of the elephant will be 3000 kg. Okay, times your gravitational field strength, 30,000 kg. Pressure would be your newtons. Oh wait, sorry, I think this one has a mistake. Okay, let me see if I can edit. Okay, I can't edit, but do take note that this should be 30,000 newtons, okay? This should be 30,000 newtons, not kg. So your pressure will be weight divided by 0.4 meter square times 4. Why times 4? Elephant have how many foot? 4 foot. So you need times the total area. And you will get this. Okay. Last question, we need to state and explain whether it will be more painful to be stepped on by the lady's stiletto or the elephant's foot. Okay, which one will be more painful? Look at the pressure. Lady is 22,500 pascals. This is 18,750 pascals. Which will be more painful? Obviously, the one with the higher pressure, which will be by the lady. Okay, the pressure is greater. Okay, you may ask, how come like the lady will exert more pressure? You see, even though I have a lesser weight, it's comparing 450 newtons versus your 30,000 newtons. Yes, I do have lesser weight, but your area is bigger. Okay, that's why it is possible that the pressure here will be higher. Because here, you see, your heels is only this small, you know. But you compare the surface area over here, it's a lot bigger. So because your force is spread out over a wider surface area, it will be less painful. Let me give you an example. So for example, you put like one like toothpick, for example, one toothpick. You do not try this, okay? I'm just giving an example. Like you put one toothpick on you accidentally prick yourself on the finger versus when you spread it out towards your whole hand, which will be more painful. It will be your prick. Because why? It's your lesser surface area. I'm not dividing the force equally. Similarly, when let's say I'm carrying a heavy object, let's say one person carry the 30 kg object versus 4 people that carry it, which will be less painful? Definitely the 4 people carrying it, because while you're sharing the weight, okay, you're sharing the force, so it'll be less painful. Okay, so that is it for this video. I'll only be going through till question 9. I think your tutor will go through the rest of the questions with you. Okay, so yeah, thank you.